5. Generative media, audio and video overview of generative AI for audio and video synthesis. Generative AI for audio and video synthesis refers to the use of artificial intelligence techniques to create new and realistic content in the form of sound and visual media. This field has seen significant advancements in recent years, thanks to the development of deep learning models, particularly generative models like generative adversarial networks (GANs) and variational autoencoders (VAEs). Here's an overview of generative AI for audio and video synthesis. Audio synthesis. 1. Waveform generation. GANs and VAEs. These models can generate realistic audio waveforms by learning the underlying patterns and structures from large datasets. WaveNet. Developed by DeepMind, WaveNet is a deep generative model that directly models the raw audio waveform, producing high-quality and natural-sounding speech and music. 2. Music composition. Magenta Project. An open-source research project by Google, Magenta explores the intersection of AI and creativity. It includes tools for music generation using deep learning. 3. Voice synthesis. Tachytron and WaveNet-based models, combining text-to-speech (TTS) systems like Tachytron with high-quality waveform models like WaveNet, has resulted in more natural and expressive synthetic voices. Video synthesis. 1. GANs for image generation. StyleGAN and StyleGAN2. These GANs can generate highly realistic images, and they have been applied to video synthesis by extending the techniques to generate coherent sequences of frames. 2. Deep video generation, Vid2Vid. This model can generate high-quality videos from input semantic segmentation maps, enabling the transformation of label maps into realistic videos. 3. Human pose estimation and animation, Deep Pose. AI models can estimate human poses from images and then animate them realistically, enabling the generation of lifelike human movements. 4. GANs for video deepfakes. Deepfake technology. GANs have been used to create convincing deepfake videos by swapping faces or modifying content within existing videos, raising ethical concerns regarding misinformation and privacy. Challenges and considerations. 1. Ethical concerns. The ability to generate highly convincing audio and video content raises ethical issues, including the potential for misuse such as deepfakes. 2. Data quality and bias. The quality and diversity of the training data significantly influence the generated content. Biases present in the training data may also be reflected in the synthesized output. 3. Computational complexity. Training sophisticated generative models requires substantial computational resources, limiting accessibility for some researchers and developers. 4. Real-time synthesis. Achieving real-time audio and video synthesis remains a challenge due to the computational demands of high-quality content generation. In conclusion, generative AI for audio and video synthesis holds great promise for various applications, including entertainment, content creation, and virtual environments. However, researchers and developers must address ethical concerns and continue refining models to enhance realism and mitigate potential biases. Using audio and video synthesis for marketing and advertising. Marketing and advertising can benefit significantly from using audio and video synthesis technologies. Here are several ways in which these advancements can enhance marketing and advertising strategies. 1. Content creation and personalization. Dynamic ads. Audio and video synthesis enable the creation of dynamic and personalized advertisements. Marketers can tailor content based on user preferences, demographics, and behavior, creating more engaging and relevant experiences. 2. Cost-effective production. Automated content generation. AI-powered tools can automate the generation of audio and video content, reducing the time and costs associated with traditional production. This is particularly beneficial for generating variations of ads for different platforms or target audiences. 3. Virtual spokespersons. Synthetic voices and faces. AI can create virtual spokespersons with synthetic voices and faces. This allows companies to develop consistent branding across different media without the need for a human spokesperson, and it can be especially useful for international campaigns. 4. Personalized audio advertising. Targeted audio messages. Audio synthesis can be used to create personalized audio messages for individuals or specific audience segments. This can be employed in audio ads on platforms such as podcasts or music streaming services, enhancing relevance and engagement. 5. Interactive and immersive experiences. AR and VR marketing, video synthesis technologies, especially in combination with augmented reality (AR) and virtual reality (VR), can create immersive and interactive marketing experiences. This can be applied in product demonstrations, virtual try-ons, and interactive storytelling. 6. Localization and global campaigns. Language adaptation. Audio synthesis can facilitate the adaptation of marketing content into different languages, allowing global campaigns to maintain a consistent brand voice while resonating with local audiences. 7. Social media marketing. Short-form content generation. AI tools can assist in the creation of short-form videos optimized for social media platforms. This is crucial for capturing the attention of users in a brief time frame. 8. Data-driven creativity. AI-generated creatives. AI can analyze data to understand what resonates with the target audience and generate creative content based on those insights, leading to more effective advertising campaigns. 9. Real-time personalization. Adapting to user behavior. AI models can analyze user interactions in real time and adjust the content dynamically, ensuring that advertisements remain relevant and engaging throughout the user journey. 10. Storytelling enhancement. Narrative generation. AI-driven tools can assist in crafting compelling narratives for marketing campaigns, ensuring that the storytelling aligns with the brand message and values. Challenges and considerations. Ethical use. Marketers need to ensure that the use of synthetic content adheres to ethical standards and avoids potential issues related to misinformation or deepfakes. User privacy. Personalized content creation should respect user privacy, and marketers must comply with data protection regulations when leveraging user data for customization. In summary, audio and video synthesis technologies offer marketing and advertising professionals powerful tools for creating personalized, cost-effective, and engaging content. However, it is crucial to navigate ethical considerations and privacy concerns to build trust with consumers. Generating lifelike avatars using generative AI tools. Generating lifelike avatars using generative AI tools typically involves leveraging advanced generative models, such as generative adversarial networks (GANs) or variational autoencoders (VAEs). These models can learn to generate realistic human-like faces or avatars based on a dataset of existing images. Here's a general process for generating lifelike avatars using generative AI tools. 1. Collect and pre-process data. Gather a diverse dataset of high-quality images featuring human faces. This dataset serves as the training data for the generative model. Pre-process the images by normalizing pixel values, resizing, and augmenting the dataset to increase its diversity. 2. Choose a generative model. Select a suitable generative model. GANs and VAEs are commonly used for avatar generation. GANs, in particular, are known for their ability to produce realistic images. 3. Train the generative model. Train the chosen model using the pre-processed dataset. During training, the model learns The underlying patterns and features of human faces. GANs consist of a generator and a discriminator. The generator generates fake images, and the discriminator evaluates their realism. The training process involves the generator trying to create images that are increasingly difficult for the discriminator to distinguish from real images. 4. Fine-tuning and optimization. Fine-tune the model parameters to achieve the desired level of realism and diversity in the generated avatars. Experiment with hyperparameters, model architectures, and training strategies to optimize performance. 5. Style transfer and control. Implement techniques for style transfer or control. This allows customization of avatar characteristics, such as age, gender, hairstyle, and facial expressions. Conditional GANs, for example, can be trained to generate avatars with specific attributes based on input conditions. 6. Post-processing. Apply post-processing techniques to enhance the visual quality of generated avatars. This may include adjusting colors, smoothing edges, or refining facial features. 7. Interactive interfaces for customization. Develop interfaces that allow users to interactively customize their avatars. This could involve sliders or other controls to adjust various features in real time. 8. Ethical considerations. Be mindful of ethical considerations, such as ensuring the generated avatars do not perpetuate biases present in the training data. Establish guidelines for responsible and inclusive avatar generation, avoiding unintended stereotypes or harmful representations. Tools and frameworks. Popular deep learning frameworks like TensorFlow and PyTorch provide the necessary tools for building and training generative models. Pre-trained models, such as StyleGAN2, may be utilized as a starting point and fine-tuned for specific avatar generation tasks. Challenges: generating diverse and inclusive avatars that represent various ethnicities, ages, and genders without biases. Balancing realism with the need for creative and expressive avatars. Addressing potential ethical concerns related to privacy and the unintended use of generated avatars. Creating lifelike avatars using generative AI tools is an evolving field, and ongoing research is focused on addressing challenges and improving the capabilities of these models.